Elasticity is an important feature of cloud which handles addition and reduction of resources on cloud. Here we are, the team Cloudera that has come up with a model that improves the elasticity of resources in the cloud by making use of CPU utilizations, workload prediction algorithm, and a trigger strategy that improves the elasticity and achieves cloud computing elasticity mechanism with automatic scaling delay of resources. We achieve this with the help of Dockers. Dockers are software containerization platform. They are different from virtual machines wherein multiple instances of operating system can run with shared libraries and kernels. So here is a system model. As you can see, there are different VMs, and on each VM, Docker resides. And we have one VM on which we don't have the Docker. We get the CPU and monitoring data through a CPU util function, and that is fed to the workload predictor algorithm. And the workload prediction outputs the workload for a predictor for workload prediction and gives it to the trigger strategy. And trigger strategy says whether to migrate or not with 1 or 0. And then comes the elasticity mechanism that migrates the container from one VM to another VM. So now here is our activity diagram wherein we have virtual machines, the Docker framework, and the workload prediction. And what I've said can be seen as an activity like the VMs giving the CPU util data to the workload prediction, and the process goes on and on. So now quickly, like before we jump into the code, I want to say what features of cloud that we are addressing. The features of cloud that we address are the resource pooling, wherein we shift the containers without affecting the user interaction. We address rapid elasticity, since we are improving the quality of service in cloud by predicting workload and migrating containers. We are addressing metering capability, since we get the CPU monitoring data of resources on the cloud. So before you see the demo, you can see that this VM is heavily loaded with maximum CPU percentage, that is 80.8, that is maximum. And now we'll run our script. Before I run the script, I should tell you like what each of the program here does. Migration strategy, it contains the algorithm, the pattern matching algorithm, and the trigger strategy within it. The migrate.sh is a shell script for migrating the container from one VM to another VM, and the final.sh that takes the migration strategy and says whether to migrate or not. So here the migration begins, and you can see the CPU percentage now. Yeah, it has. Yeah, it has reduced from 80 point to 51 percentage, 49.5 percentage. Yeah, since the migration has completed. So this is the image prod.tar that has been shifted from the source to the destination machine. And here at the destination machine, we run the script again, and the image has been loaded over here on the destination. So the image has been loaded and it started running. And this is the image. This is the Ubuntu image that we have that we are running. Yeah, and now we'll do Docker images, image. Yeah, so here is the project, that is the image. This is the latest image that we have along with its image ID. So that's it from demo. Lastly, I would like to say the benefits of this project. Firstly, it improves the quality of service since the elasticity is being increased. And secondly, we are improving the user service level agreement. Like the processes run faster on Docker with zero user interaction. So that's it.